So the third level of measurement, guys, just pay attention and let's see if you can give me an example. It's a quantitative data. It's a number. Data can be ranked, ordered from lowest to largest or largest to lowest. Difference between data entries is meaningful. You can subtract, and then it has a meaning. The zero means something, represents a position on a scale. So the zero at this level means something. It's not that like nothing. Like if I tell you I have $0 in my wallet, that means I have nothing. But no, the zero at the interval level means something. So can you guys give me an example of a data set where you can order the data from lowest to largest, and if you can subtract it, it will make sense to subtract, just a data. And the zero means something. It's something that you can feel.
Temperatures?
Yes, that's the most common example. Temperature.
And I have one more.
That
Can
would
we
be,
say the sea level, like
yes,
and
below zero and after above zero. Yeah. Yeah. But temperature, guys, is the example. It's the most common example. And I'm going to explain to you why this makes sense. Because, guys, when it is 0 degrees Fahrenheit, I would prefer for it to be 0 than being 15 or 20 below 0. So the 0 is something that we feel. It is a temperature, and it is. And you can go above 0, below 0, etc. So temperature is one of the examples because the 0 means something. You can subtract to temperature, like for example, if it is 50 degrees in Dearborn today and 70 degrees in Phoenix, Arizona, the difference is 20. It makes sense to say it's 20, so it has a meaning. Okay, here you go. I got another one. Weight, no, but year, yes. Year. We use a Gregorian method, just for the years. And so when it was the year 00, it doesn't mean that there was no time or there was nothing. It was before, just Christ and after Christ. So that is another example that you can use. And you can build examples, just like the student said, just a sea level. If you go like below sea level, you have to use negative. Above sea level, you have to use a positive. And at sea level, it's 0. So it does mean something. One thing you need to know about interval level, guys, you cannot say that one quantity is twice the other quantities or 3 times the other quantity. I'm going to give you an example. Let's say in the winter time, it's 1 degrees Fahrenheit in Dearborn, and it is 2 degrees Fahrenheit in Livonia. Can you say that it is twice as cold in Livonia than it is in Dearborn? Because it's 2 times as much. Does that make sense? Will you guys be able to tell the difference if it was 1 degrees or 2 degrees outside? Actually, you won't be able to tell the difference. So you cannot compare this way, just with temperature. And I'm going to give you even another example that will convince you, actually. If it is 40 degrees here in Dearborn and 80 degrees in Las Vegas, will you be able to say that Las Vegas is twice as hot or as cold as Dearborn? That doesn't make any sense, because that's hot, guys, and that's cold. So we cannot compare by using ratios. We can do differences, we can add, subtract, but 80 is twice as cold as 40, or 80 is twice as warm as 40. That doesn't make sense to say that. So we don't compare this way at the interval level. All right. Now, I would just probably, if you go to your 24-hour clock, guys, when you use 24-hour clock, then you can use it as an interval level, because 000000 on your clock means midnight. That's another example. But these are the most common examples in a particular temperature. The last one, ratio level of measurement. It's similar to the interval level. Quantitative data, you can rank the data, you can subtract, but you can compare using ratios. You can say 80 is twice as much as 40, but the 0 means nothing at the ratio level. So the 0 is nothing. Like I have no money in my wallet, that means I have $0. That is what the ratio level of measurement. Can you guys give me some example of ratio? Probably, actually, anything you come up with should work. As
Age.
age, okay.
Weight.
What did you say?
Weight.
Weight. Yeah.
Height.
Height. Income. If I don't get paid, just on the 15th, that means I made $0. So no money. Anything else? Don't say temperature. Temperature won't fall there. It's and let me tell you what it makes sense, just to compare using ratios. For example, weight. If someone is 50 pounds, a child, and another person is 200 pounds, you can say that the 200 pounds weighs 4 times as much as the 50 pounds. It makes sense. It's nothing wrong with making this statement. So it does make sense to you. And that's why actually they call it ratio. All right. Okay, let's give you an example. 2 data sets are shown. Which data set consists of data at the interval level? Which data set consists of data at the ratio level? I'm going to show you that data. New York Yankees World Series victories in years. So what would that be? The years.
internal.
Yeah, we said interval for years. Okay, let's see the second one. 2008 or 9 American League home run totals. How many home runs? So would you guys agree it's a ratio? Because if a team, let's say, has a home run of 100 and another one has a home run for 200, you can say that 200 is twice as many as the 100. So it does make sense. And that is the difference between interval and ratio. Most of the time, guys, most of the work we'll be doing is at the ratio level. And let me give you a summary of the 4 levels of measurement. Okay. Nominal, you can put the data in category. Yes, it's qualitative. You cannot arrange the data in order. Subtracting has no meaning when you subtract 2 words. And if one value is a multiple of another, that means you can compare them as multiple of each other. You can't, so no. Ordinal, yes, it is either qualitative or quantitative. Arrange data in order, we can, but the other 2 is no. Interval, yes, it's a quantitative data. You can arrange data in order. You can subtract data value. It has meaning, but you cannot say one is twice as many as the other. So, and ratio, it's all yeses. That's why it's very important to us. It does everything. But remember, the 0 at the ratio level means the inheritance 0 means nothing. Okay. Any questions?
So on the nominal, it just says you can arrange the data in order.
No, you can't. Like for
Oh.
example, if I tell you list possible, eye colors, you give me a list. Why should brown come first? Why should blue
Oh, okay.
why blue doesn't come first? Why green? You just list them, but you cannot rank them. But when I give you a letter grade, A, B, C, D, yeah, you can argue A is the top grade and B, C,
Okay.
and D, etc. Yeah, I have my lawn service, just outside now. So I do apologize, guys, if you hear the noise from outside. All right. Section 1.3, that's the last section. And actually this part here, it's it's not gonna be required, but I've just thought, just to make you aware of it. So I won't be testing you on how to design a statistical study. When you do actual research, just you have to be aware of it. But I'm just gonna show you how good statisticians, design a statistical study and plan on collecting data. So first of all, you need to know why you're doing your study. What is it that you want to find out about? So identify the variable of interest. Like you want to survey students on how many credit hours, they have. So that's the question that you wanted to ask. Develop a detailed plan for collecting data. If you use a sample, make sure that the sample is a good representative of the population. So for example, if you want to collect data at the college, you cannot just go to one department, and collect the data from those students in that department, because it is possible that those students to belong to a certain department could be taking more credit hours or less credit hours than other students. So you have to make sure that your data represents the entire population. So I would go and collect data from all departments at the college. Collect the data, describe the data display the data in a graph, bar graph, pie chart, etc., and then make decisions about the data using inferential statistics. What's going to happen in this class, guys? We're going to skip the 1, 2, 3, 4. That should be a 4, 5. And we're going to give you, just the data set and then ask you to interpret the data and make decisions about the population. So the data will come to you. You don't have to go and collect it, especially during COVID-19. How do we collect data? So this, guys, I won't be assess you on this, because we will not be going and collecting, just actual data. But how to collect data, the methods of collecting data, you need to be aware of it. And we're going to begin with observational study. So let me tell you what observational study is. And actually yesterday, guys, you did give me some feedback, and you shared actually all the 4 ways of collecting data with me. So I'm just going to repeat them. So what's observational study? A researcher observes and measures characteristics for interest of part of the population. The observer doesn't do anything. It just sit down and watch and take notes. So here's an example. Researchers observed and recorded the mouthing behavior of non-food objects of children up to 3 years old. So children are playing, just and putting objects in their mouth. You just sit down, watch them and see what they're doing and take notes. That's observational study. Experiment. And that's what's happening, guys, with the experiment on the vaccines. Or they are all doing exactly the same thing that I'm going to list it, or they're still doing it probably until this moment. A treatment is applied to a part of a population, and responses are observation. Here's an example. An experiment was performed in which diabetics took cinnamon extract daily while a control group took none. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease, while the control group experienced no change. So for your information, guys, the way they're doing, just COVID-19 experiments, they bring in 2 groups. One group gets, the vaccine, and another group gets placebo, sugar pill, nothing. And probably they don't tell them. And they just monitor them and see who gets, just the virus and who doesn't get the virus. And this is how they came up with a 95%. Like out of 200 people, only 190, just did not get the virus. And that's why they came up with the figure 95% efficacy. It's the same thing. So every time you do an experiment, guys, you have to bring 2 groups for the sake of comparison. It wouldn't be just one group. One group gets the treatment and the other one gets nothing. And then you just compare the results and make conclusion based on the results. Survey. We talked about it yesterday. You mentioned that this one way of collecting data, this is very important way. It's commonly done by interview, internet, phone, mail, an investigation of one or more characteristics. In the survey, the nice thing about the survey, guys, you can put as many questions as you want in there. So this is an example. A survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. So that's the title of the survey, and then you can put questions in there. The fourth one is simulation. If it is not possible to do the real thing, guys, probably you have to simulate it, use a technology or computer model. So use a mathematical or physical model to reproduce the conditions of a situation or process. It often involves the use of computers. So here's an example. Automobile manufacturer use simulations with dummies. They're not gonna bring real people and see if the two cars collide, what will happen, because there's a chance that the person, will die or will get, severely hurt. So to study the effects of crashes on humans, that's how they do it. They use simulations. They put dummies in the cars. And I think you've seen that, guys, before. Any questions with the 4 here? What we're gonna do now, I'm gonna give you an example with 4 categories, and I want you to label them as survey, simulation, experiment, or observational study. And we're gonna begin with number 1. A study of the effect of changing flight patterns on the number of airplane accidents. What do you guys think this one is? Yeah, I got 2 responses in chat. Simulation, I agree. Definitely, they're not gonna do the real thing here. I wouldn't volunteer if I was a pilot, just to do this. Okay, a study of the effects of eating oatmeal on lowering blood pressure.
Experiment.
Yeah. And the chat agrees as well.
Experiment.
I agree. Here's what they would do, guys. They bring 2 groups. One group will be taking the oatmeal and another group will just do nothing. And they just watch him for 5-6 months, and they will take, their blood pressure before, and they will take their blood pressure after, and they compare whether there is a change or not. If they get the same results with the 2 groups, then they conclude that the oatmeal is not effective. If they get better results with the group who ate oatmeal, then they can decide that it is what it says. It does what it says on lowering blood pressure. A study of how 4th grade students solve a puzzle.
Observational.
Yeah. You just observe them because you didn't interfere. You said you just how they do it. All right. And a study of US residents' approval rating of the US president. I think you agree, guys. You have to ask questions here. That will be a survey. I agree. Okay. So these are the answers to the questions. And that's a summary of what I just touched on. Just read it, guys. If you understand the definition of each one, you shouldn't have hard time just right away figuring out, just what the answer is. All right. Okay. This is also not assessed, but I thought to include it just for your information, how statisticians design an experiment. There are many times, guys, where we statisticians do a study to see if something that is happening affect, just something else. But it turns out that there is something else that's happening that they're not aware of, and causing, just things to change without noticing. For example, I'm going to give you this example, and this is called a confounding variable. For example, if a coffee shop owner remodels her shop, the coffee shop owner remodels her shop because she or he wants, just to generate, just more business and profit as a result of remodeling. But at the same time, a nearby mall has its grand opening. If the business of the coffee shop increases, it will be hard for the owner to tell whether this was a result as a remodeling or it was a result of the new mall opening, because the new mall is going to generate more traffic. So you wouldn't be able to tell what caused, just the profit to increase. It could be both. It could be one of them. It could be just the mall. And that's what we call a confounding variable. Okay. The placebo effect, you know what, sometimes some people, like when they get sick, even if when they go to the doctor, even if the doctor prescribes something that doesn't help with anything, but it's the psychology, just of the brain, you're taking medication, you start feeling better, and that's what we call the placebo effect. Placebo means a water pill, a sugar pill, it has no effect, but some people reacts, favorably to a placebo, when in fact, just they were given nothing. That could happen in a statistical study as well. Blinding, if you want to do an honest and unbiased study, you do blinding. Is a technique where the subject doesn't know whether they got the real, like if you're testing a new medication, you don't tell the subject whether you're giving them a real medication or giving them a placebo. So that's called blinding. Double blind, it's when the person who is administering, just the treatment doesn't know whether he is given a treatment or is given the placebo. So it's all randomized. What I'm trying to get into, guys, into statistics, the more you randomize your study, the more reliable, just the results. Do everything at random. Don't think in a biased way. And randomization is a process of randomly assigning subjects to different treatment group. So these just an idea of, I won't be asking you, just a specific question, but I thought to put this in there so just how the experiments are designed. Okay, what you need to know is the sample size. What do you mean by a sample size? The sample size is the number of subjects in a study, and it is very important, guys. If you're studying a very large population, let's say if you want to take the citizen of Dearborn, we have about 100,000. You cannot just put 7 or 8 people in the samples and say that's going to reflect on the entire population. That is a very small sample. And definitely you're not going to put, just a sample in the thousands or tens of thousands, because that's going to cost a lot of money and time. So you have to have a reasonable, just sample size always. Okay, replication, we don't have to worry about it. Just focus on the sample size here, guys. So how many in the sample? That's what the sample size means. And the last thing we're gonna do with chapter 1, guys, is how do statisticians collect their samples? What are the techniques that they do for sampling to collect a sample? Let me give you a definition of a random sample. A random sample, every member of the population has an equal chance of being selected. Most of the samples, all of the samples, guys, actually, that you're going to see in the book reference to, they're going to say a random sample, because you want to do an honest statistics, your sample must be random. So I have 30 students in my class today, guys. If I ask you, I want to select 5 students now and put them in a sample. Can you help me figure out a way to collect a random sample from those 30 students? What would you suggest?
Put their names in a basket and pick 5.
You got it. Put the names in a basket and pick 5 and don't look without looking. That's an excellent way to do it. That would be a random sample, guys. It could be, it turns out, just to be 5 females, and although probably I have more males than females, but it is random sample. It's unlikely that for this to happen, if there are more male than female students in my class, it's likely that the sample will have more male than female. But if it happens otherwise, your sample is random. You didn't interfere, just to pick your sample. So that's what a random sample. Now, let me tell you what a simple random sample is. Every possible sample of the same size has the same chance of being selected. So let's say I have 30 students. I want to pick 5 students. So any 5 students could be together in the sample. We don't know who's going to be together because I'm collecting, just the numbers at random. But it means that will be a simple random sample. If you put the names in the basket, guys, and you just collect 5 names, it will turn out, just to be a simple random sample, because any 5 students will have the same chance of being together in the sample. But I'm going to give you an example, guys, of a sample that turns out not to be a simple random sample. So I'm just going to draw that, and you tell me why this is not a simple random sample. So here's the example. Watch. You are in the class and you are seated in rows, and I have 6 rows, 5 students sitting on each row. Let me just move this a little bit. Okay, that's row 1, that's row 2, row 3, row 4, row 5, row 6, and I have 5 students sitting in each row. Okay. I'll prepare 6 pieces of paper, and I'll put row 1, row 2, row 3, row 4, row 5, row 6. I'll put them in a basket. I want to pick 5 students. So I have the basket with 6 pieces of paper, identical, put R1, R2, R3, R4, R5, put them in a basket, and I ask students to select one. And then once we select one, let's say it turns out to be row 1, we tell those students in row 1 to be in the sample. So they will be the sample because there is 5 on each one, 5 students each. This is not a simple random sample, guys. Can you tell me why?
Because you didn't pick from each row, like you pick only one row from the same group.
Okay, what causes this not to be a simple random sample? What's the violation here?
They are sitting next to each other and they are in the same group. So you need to pick one from each row, then it will be better.
Better, but okay, you're getting there, almost there.
what
I'll
about-
give you one counter.
Sorry, what about let's say those students know each other, they're friends, so then you're just picking people that they
That's
know.
right. That's the reason.
Yeah.
But okay, let me tell you why it's not a simple random sample. That means the students who's sitting here and another students who's sitting there in row 1 and row 4, they will never be together. And that's a violation of the definition, because the definition, it says any 5 students from anywhere have the same chance of being selected and being in the sample. As you said, guys, only those 5 will be in a sample. Only those 5 will be in the sample. 5 together. That means this students here, 1 student, a third students here, a 4th and a 5th will never be together. That's not a simple random sample. If you ever think of a simple random sample, guys, think of putting names in a basket and collecting, whatever you want to collect, 5, 6, 7. That's a simple random sample. Okay. Here's an example for a simple random sample. There are 731 students currently enrolled in statistics at your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. Okay, I'm going to show you how to use a table. If I provide a table, you can do that. Your calculator can select. So here's one way to do it, guys. You can put 731 numbers in a basket and collect, just 8. That would be the best way. But if it's not possible to write down 731 names and just put it in the basket, probably you want to refer to technology to do it for you, or to the table that I'm going to show you in a second. Okay, in a table of random numbers, choose the starting place at random, and I'll show you how you can pick them. So if you see this in the homework and they're asked you to pick some names, I'm going to show you how to use this table. Okay. First of all, we have 731 students. So the largest ID is a 3-digit. Just to be fair, guys, all students have to have a 3-digit number. So it has to have a 3-digit. If the college ID, guys, like it has 6 digits, I can tell you guys, all students have a 6-digit ID. Even if their number has only 5 non-zero digits, the first one will be 0. So how would you identify number 1 as a 3-digit number? What would you write it? How would you write it down?
Add zeros.
Yeah. So actually 001, 002, 003, and so on and so forth. That's what we call a 3-digit. So, and let me show you how to use, so remember we have 731 students. And we want to pick 8. And I want to show you how to use the table to pick 8. If this shows up on the homework, there will be an arrow telling you what to start. So we're starting here. Start reading 3-digit at a time, guys. So let's read the first 3 digits. What's the number here? 700 what? 19. Ask yourself, is there a student whose number 719? Well, the answer is yes, because I have 731. So that's below 731. So that's the first student in the sample. Okay, let's go to the next 3. 662. Yeah, there is a student by this number. Let's do this one. What about 738, guys?
No.
We pick the students, or there is no students with number 738? No. So we go to the next one. 650. Yeah, there is a student. You were wondering, probably the single-digit students will never be picked. No, look at this one, guys. 004. See, that's from the single-digit one. Okay, let's go to the next one. That's in the sample. You keep going until you get what you want. 589, that's in the sample.
And what is it that you want?
We want 8 students.
Oh, okay.
So we're picking 8 students using the table. And we're just starting, just anywhere in the table, and we're just gonna collect 8 students. The next one will be 403. How many do I have so far? 1, 2, 3, 4, 5, 6, 7. I need one more. And this one should work. 129. The bottom line, guys, is if you come across a 3-digit number that is more than 731, you don't consider it. Anything that is less than 731, you just put in the sample. If the same number repeats, let's say you pick 719 and you get 719 later, you don't pick it because you're not going to pick the same student twice. And that's how you use the table. That's not very important, guys. You might probably see just one question using tables. Nobody uses tables anymore because of the presence of technology. Your calculator can do this. which I'm gonna demo this in a second, show you how can you pick, just 8 digits using the calculators. So here's how you do again. You go to math, probability. See, technology is much faster. I will never ask this question on the test because no 2 students are going to get the same answer. And watch. You see, even number 2 turned out to be one of those members of the sample. This is how you generate a sample using technology. How does the calculator pick those numbers? It's a very complicated program. I don't know, but that's how you do it. Okay. So we have random samples. That's the first sampling technique, simple random sample. We're going to learn about the remaining sampling techniques, guys. There are 4 more, and I'll explain them to you right now. Stratified sample. Okay. That shouldn't be here. Here's what stratified sampling technique works. You want to pick a sample from a population. You divide the population into sections. They call them stratas. And then you go and get members from each section, and then you put them all together in the sample. And here is an example here. To collect a stratified sample of the number of people who live in West Ridge County households, you could divide the households into socioeconomic levels: low income, middle income, high income. And then you go pick some from the low income, some from the middle income, some from the high income, and put them, just all together to make your sample. And that is what we call a stratified sample. I wonder, guys, if you notice here, in the first group, we picked 2. In the third group, we picked 2, but in the second one, we picked 3. Why is that? There is no consistency here, but there is a good reason for that.
The group is larger.
Exactly. Your sample has to be a good representative of the population. If there are some more middle income, then they have, just a higher voice, guys. You have to consider that. Since there is more in the middle income, you have to put more in the sample and just keep it, just consistent this way. So that is what a stratified sample is. Stratified sample is good to use when you go to a population where there are different groups who have different opinions and different characteristics, and you want to represent all of them. So you just split them up into pieces and go to each piece, just and pick, just from each piece and put in the sample. Another example, guys, I can think of, let's say I want to pick, just a sample of 500 people in Dearborn. I could divide Dearborn into zip codes, and I'll go to each zip code area and pick people from there and put them in the sample. That's another way, just to think of stratified. Now let's go to cluster. How does cluster sample works? Divide the population into groups. They call them clusters. And select all of the members in one or more, but not all of the clusters. So here's an example, guys. In the West Ridge County example, you could divide the households into clusters according to zip codes: zone 1, zone 2, zone 3, zone 4, zone 5, etc. And then select all the households, for example, in zone 1, and that would be your sample. That would be a good, to do technique, just if all the sections, the segments have very much the same characteristics. So then it doesn't matter where you pick from, whether you picked entire zone 1 or entire zone 2, zone 3, zone 4. It's just going to cover, just the entire population. but this is another way that statisticians, just do to collect samples. They use a cluster samples. Any questions about this? We will do many more examples later, guys, to just distinguish between those sampling techniques. Systematic sample, that's an easy one. You choose a starting value that at random, and then choose every kth member of the population. And let me show you an example. There's an example right here. And the West Ridge County examples, you could assign a different number to each household and randomly choosing a starting number, and then select every 100th household. So just to make it simpler, guys, let's say we are in the classroom and I want to pick a sample of 7 students. I can stand by the door when you walk into the class, and I say the students who's going to walk in at 9 o'clock, I'm going to put that students in the sample. I don't know who's walking in at 9. So the first students arrive at 9. I'll tell that students you are in the sample. And then I say, I'm going to pick every 4th students. So I'll just count 1, 2, 3, the 4th is in the sample. 5, 6, 7, 8, the 8th in the sample. 9, 10, 11, I invite the 12 students to be in the sample, and so on and so forth. So you just create a system and stick to it, an interval. I want to do the every 5th, the every 6th, the every 2nd. That's what a systematic sample is. Convenience sample. This is not a recommended sampling technique because it often leads to biased study. Choose only members of the population that are easy to get. And I'll give you an example of a convenience sampling technique. Let's say I want to survey students on the distance and the time they commute from home to school. So I prepare a survey. I want to collect data on commuting time. And let's suppose it is January. It's very cold outside. It's snowing, heavily snowing. And only 5 or 6 students showed up to class, including me. So, and then I say, I want to do this sample. I'm not going to delay it. So I'll ask those 5, 6 students to fill out the survey. And that would be called a convenience sample. Why? And it does lead to bias, actually, guys. What do you think? What's not good about doing this?
Because maybe they are the closest to the college, or
You got it. You got it. Those students probably showed up because they live, just at a very close distance to the college. Probably they live on campus in the dorms if we have dorms. So that would not reflect on the actual, just classroom experience, the entire classroom experience. And you guys, you should agree with me that this is going to lead to biased, just results. And then biased conclusion. Because if I use this sample to make conclusion, I'm going to make a conclusion that the distance that students commute, to school is a very short distance, which is not right, because I only considered those students who showed up to class. Okay. And let's do, tell me what sampling technique is being used here. You are doing a study to determine the opinion of students at your school regarding stem cell research. Identify the random sampling technique used. So let me remind you of the sampling techniques, guys. Simple random sample, stratified sample, systematic sample, cluster sample, and convenience sample. You divide the students' population with respect to measures like physics, chemistry, biology, sociology, psychology at your school regarding STEM, and then select and question some students in each measure. What would that be, guys? So you divide them into measures and you select from each measure, every single measure.
stratified.
Yep, I agree. And I got the chat to say stratified. Because you split them up into measures And you pick from each one. I agree. 2, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected.
Simple random.
Yeah. I know probably, you see, I did this example last semester and I have a student say right away systematic, but I say, where is the system? I didn't say every 4th or every 5th. I say we're picking, just off technology, select random, generate random numbers, probably using the program that I showed you on the calculator or the table. I have no control, just of this. So this is simple random sample. All right. Okay, let's see. Okay, here's what I want to tell you about the last 2 pages, guys. It has, please leave it, keep this handy. It has a summary of everything that we have done and even a little bit more. So I would consider, if you just want to check whether you grasp the concepts, just of today's lesson and yesterday, just review, this page. It has a summary of everything that we have done. Okay. Just to show you here, this is not important to us. Just need to know what observational study, design, experimental design, confounding variables. I defined that, but as I told you, I will not be asking you. And these are a summary of the sampling techniques that we did today. Random sample, simple random sample, stratified sample, cluster, systematic sample. Actually, all right, true or false. So that's page 6 in your ebook online. Number 6, what do you think, guys? True or false? A subset is a sample is a subset of a population. True, false?
True.
True. Yeah. What about number 7? It is impossible for the Census Bureau to obtain all the census data about the population of the United States. True or false?
True.
True. Although it's supposed to cover the entire population, but they don't, guys. They don't cover the entire population. Just be aware of this. 9, true or false? Population is a collection of some outcomes, responses, measurements, or counts that are of interest.
False.
False.
It's
False.
all outcomes. That's a sample. 10. A sample is statistic. It's a numerical
False.
value that represents a sample. Will not change from a sample to a sample. That's false. If I pick 5 students and I ask what's your average age, we add up the 5 ages and divide by 5. But if I pick another 5 students, do you think it's going to be the exact same answer? No, we're going to get different statistic. All right. Determine whether the data set is a population or a sample. A survey, number 13. A survey of 500 spectators from the stadium with 42,000 spectators.
Statistic.
No, sample or population?
Sample.
Sample, yes. Number 16, the number of televisions in each US household.
Population.
Yeah,
Population.
yep. 17, the final score of each golfer in a tournament. So the tournament is the population, guys.
Population.
Yeah, it's yeah. So don't think the population has to be large. You can make it whatever you want. 18, the age of every third person entering a clothing store.
Sample.
It's a
Sample.
sample. Can you tell me what the population is, guys? So what would be the population? If this is a sample, what would have been the population here?
The age of all people.
Exactly. The age of all people entering the clothing store. That is correct. 15. The cholesterol levels of 20 patients in the hospital with 100 patients.
Sample.
Sample.
Sample. What would be the population? Could be some questions later. They will come and ask you what would have been the population.
So it would have been
100 patients.
20 out of the 100 patients.
There will be the cholesterol levels of all what? 100
All patients.
100 patients.
Patients.
Exactly. Okay, very good. This is when it's gonna come to this. All right. Now we're just gonna do, we're gonna read and interpret the population in the sample. I'd like you to do 26. So identify the population in the sample. A study of 33,043 infants in Italy was conducted to find a link between a heart rhythm abnormality and sudden infant death syndrome. What is the population, guys?
Should be all the infants in Italy.
All the infants in where? Not in the world, not in the US,
In Italy.
in Italy. Does everyone agree with that, guys, that it should be all the infants in Italy? And what would be the sample? The 33,043 infants in Italy, that would be the sample. Okay, let's do 29. You know what? Actually, I'm going to do 30 because the odd numbers, you have them in the solutions manual. So let me just do even numbers. A survey of number 30. A survey of 496 students at the college found 10% planned on traveling out of the country. No, you need to extract the population and the sample. What would be the population here?
All the students.
All the students. at the
496
college.
students.
Yeah. And then the sample will be the 496. The 10% is called a statistic. That is a description from the sample because it's from those 496 students. 32, guys. A survey of 961 major appliance shoppers found that 23% bought extended warranties. What would be the population? Population, you have to figure it out before you say what the sample is. So what would be the population?
All the appliance shoppers.
So major appliance shoppers, all major appliance shoppers. And then your sample will be the 961 shoppers. Exactly. Okay, distinguish between parameter and statistic. Number 36. A survey of 2,514 college board members found that 38% think that higher education costs what it should relative to its value.
Statistics.
It's a statistic because it doesn't say all college board members. It is a statistic. All right. 42. In a recent year, the average math score on the ACT for all graduates, you see how I raise my voice when I say all?
Parameter.
It's a parameter. 38, last one. In January 2013, 60% of the governors of the 50 states in the United States were Republicans.
Parameter.
It's a parameter. The 60% represent a parameter because I'm talking about all the governors. What portion of the governors were Republicans in the US? Okay. Very good. Let's go to quantitative vice, qualitative data. You can see this chapter is not difficult, guys. If you just understand the meaning of what we went over, it shouldn't be hard, just to grasp it and get it over with as soon as you can. And exercise 7 to 14, determine whether the data are qualitative or quantitative. Height of hot air balloons. What do you think?
Quantitative?
Quantitative. Okay. Carrying capacities of pickups.
Quantitative.
Quantitative, that's the weight. Eye colors of
Yeah.
models.
Qualitative.
Student ID.
Quality.
Qualitative. Weights. Once you see the word weights, guys, it is quantitative. So that's infants at the hospital. Species of trees in a forest, that's qualitatives. Responses on an opinion poll, it's usually our words that you select words, so that is qualitatives. And then wait times, definitely that's a quantitative, that's a quantity. All right. Number 18, I'd like you to tell me whether this is nominal, ordinal, interval, or ratio level for number 18. The length in seconds of songs on an album are listed. So the length of a song, what would that be categorized as, guys?
Nominal? Or
Why would that be nominal? It's a number and it's in seconds.
then it should be ratio?
It should be ratio. You could have a length of the song 0 seconds means that there is nothing in there. As
Yeah.
long as a 0 means nothing, guys, it turns out to be, it will be a ratio. What about 19, guys? Bestsellers list. This is all qualitative data, but they were ranked 1, 2, 3, 4, 5. 1 being the bestseller and 2 the second best, and so on.
This is ordinal.
That is ordinal, exactly. All right, let's see what we're gonna do next. So guys, you need to identify the sampling technique used, whether it is a simple random sample, stratified sample, cluster sample, systematic sample, or convenience. Using random digit dialing. Researchers call 1,400 people and ask what obstacles such as childcare keep them from exercising. What do you guys think?
Simple random?
Yep, because you use random digit dialing. You don't know what the number is just gonna pop up, so. Is there a potential source of bias here, if any?
It would be.
What is it? What would that be?
Maybe some people won't answer or won't
That's
participate.
right, and some people even don't have phones.
That's true.
Although it is good sampling technique, but there is a little bit of bias there. 24. Chosen at random, 500 rural and 500 urban people age 60. So you're gonna think of it, guys. People either are in urban areas or rural areas. So you pick 500 from the city and 500 from the country, and you ask them about their health and their experience with prescription drugs.
Cluster?
Cluster, you have to pick, if you divide the population into segments, you have to pick everybody in the segments. But here we only picked 500 from the city and 500 from the countryside.
Oh, those stratified?
Stratified, do you guys agree? We divided the population into 2 types. People
Yeah.
who live in urban areas and people who live in rural areas. We pick 500 from one side, 500 from the other side, put them together. So we have 1,000 altogether that is stratified. All right, let's see what you think of 25. Take your time to think about 25.
It's not appear on the camera.
Oh, what about now?
No,
Oh, you guys don't see number 25?
I can see it.
I can see it now.
Okay. Questioning students as they leave a university library, a researcher asks 358 students about their drinking habits.
Convenience.
Who said convenience?
Me.
Oh, Marwa, why?
Because they were the first students who get out of the library.
Okay. It is
Yeah.
convenience because it's
Of
only
their
done
friends.
at the library. It is just the person did not even bother to go and survey other students. It could have been that those students gathered, at the library, they have an event, just and probably drinking, just was involved in whatever. I mean, it is convenience because it was done only at one place. I used my convenience. I didn't want to walk around campus and survey other students. That is convenience, guys. 26. This is a good one. After a hurricane, a disaster area is divided into 200 equal grids. 30 of the grids are selected, and every occupied households in the grid is interviewed to help focus relief efforts on what residents require the most. So what they did, they divide the population, which is a disaster area, into 200 pieces, 200 equal grids. And then they went to 30 grids and picked everybody who has a home, just on those grids and survey them.
This is a cluster.
That is a cluster, guys. I agree. It is a cluster. But is there a potential source of bias there?
Of course.
What is it?
Maybe the grids they picked, it's not the people who has more damaged, or it's the
Exactly.
area.
Exactly. This is a big thing, guys. If those grids that they selected were lightly damaged, comparing, to the other grids that they were not selected, then I think, just the ones who had severe damage are not going to get as much support as the ones, just on those grids. So, but if the damage is consistent, guys, throughout the grids, I think that's a good sample. But if it's not, then it's not a good sample. They should do stratified instead. What about 27, guys? Chosen at random. 580 customers at a car dealership are contacted and asked their opinion of the service they received.
Simple.
Simple random sample, I agree. Because they were chosen at random, guys. Okay, let's go to some more. Just wanted to have a good feel of the sampling techniques. Every 10th person entering a mall is asked to name his or her favorite store.
Systematic.
That's a systematic. 29. Soybeans are planted on a 48-acre field. The field is divided into 1-acre subplots. So you just divide them into 1-acre subplots. A sample is taken from each subplot to estimate the harvest. So
Stratified.
that is correct. It's stratified because you have 48 segments. You go to each segment and get a sample from there. That is exactly, and they should take the same amount from each sample because they are all 1 acre. What about the last one, guys? From calls made with randomly generated telephone numbers, 1,012 respondents are asked if they rent or own their residence. Do you guys agree that this is simple random sample?
Simple, random, and randomly generated.
That's correct. All right. Now, guys, the way we ask questions in statistics can lead to bias, and I want to show you some examples here. I'd like you to look at number 33. In exercise 33 to 36, determine whether the survey question is biased. Sometimes it's a good bias, guys, but bias is biased. If the question is biased, suggest a better wording. So read 33, guys, and tell me whether you think this question is being biased. And if you think it is biased, suggest another wording for this. Why does eating whole grain foods improve your health?
It looks like an answer.
That's right. You are suggesting to the person that eating whole grain food improve your health.
Yeah,
Then
telling it's improve their health, but
Yeah.
it would be better like if we ask, do you think like eating whole grain foods improve your health?
exactly. Yeah, you're implying here that eating whole grain food, you're not even giving the person a chance to argue that. So that is a biased question, although it's good. I mean, if you eat whole grain, that's good for you, but it's a good bias here. 34, why does text messaging while driving increase the risk of a crash? Do you guys agree that this is also a biased question? Although it's a great warning in this question, but it is biased. And as a student said, just if you want to reward it, you can ask, does texting, just while driving increase the risk of a crash? That's a bias. What about 35, guys? How much do you exercise during an average week?
Is it biased because some people don't exercise?
Well, you're just asking a question. You don't know whether people do. You're asking them. I see your point here, but I don't think it is biased. I'm just asking you, how many hours do you can tell me 0 hours. I'm not telling you exercising is good for you. How many hours do you exercise a week? I'm just asking a question. So you can tell me 0 and that's acceptable answer. I don't see any bias in there. What about 36, guys?
Biased.
Why does the media have a negative effect on teen girls' dieting habits? So you're implying that it's already a negative, not just effect. I would reword this one and say, does the media have a negative effect on teen girls' dieting habits? Or I would even say, does the media have a positive/negative effect? Then that will be not biased at all questions. Okay, so this is for that. And I'm gonna stop, pause the recording and ask you a couple questions.